Hello everyone and welcome to this new lecture. Today we're going to discuss about the special theory of relativity that was given by Einstein in 1905. Okay, so in the last lecture we have discussed about the Michelson-Morley experiment, and in that experiment we have discussed that how the Michelson and Morley performed that experiment, and they have assumed that there is an ether frame and they have tried to find the velocity of Earth in that ether frame. Okay, although they got the failure of this whole experiment, there was a failure of this whole experiment and they got null result. Even they have tried that experiment after rotating and even in the different regions as well. Okay, and every time they got the same result, and that is the no result as well. Okay, so at the same time of period of time, we have earlier discussed that what led to the Michelson-Morley experiment, that Maxwell was performing has given his electrodynamic equation, and in that equation he have also derived or assumed that light is an wave, and light is an electromagnetic wave, and he has also find the speed of that electromagnetic wave is 3 into 10 to the power 8 meter per second. Okay, so these all things were contradicting, whereas the Galilean transformation equation was not valid at the highest speed, and even the Galilean transformation equation was not valid enough for the Maxwell equation, because Maxwell equation was getting failed. Okay, so either Galilean equation have to be correct or Maxwell equation have to be correct. So all these things were mesmerizing and things. So in 1905, Einstein came into picture and he gave the special theory of relativity, and basically the two postulates that he gave. Okay, and this changed the whole scenario, whole things of this physics world. Okay, he said that the laws of physics will remain same in all different frame of references. Okay, and the speed of the light will be c in all different reference frames. Okay, it won't change if we change the things from one frame to another frame of reference. So let's try to understand our first law. Okay, so what the first law is saying, the laws of physics are same and can be split in the simplest form in all inertial frames. So let's suppose we have the two inertial frames, as we are already always taking that S and S dash frame, and we assume that as the frame is moving with some velocity v, and all these things are happening. Okay, so if some event occurring here especially in this frame, and if some event A, let's write A and B. Okay, if event A is occurring in S frame and event B is occurring in S dash frame. Okay, and observer 1 and observer 2 is here. Okay, so if observer 1 is watching this event and if observer 2 is watching this event, okay, so there won't any change. Okay, they will see the same result in their frame only. So all the things, all the laws of physics will remain same in their on frame of reference. Okay, and we have seen when these frames move or go in certain direction with this comparable speed of light. Okay, with the comparable speed of light. Okay, it means around half of speed of light. So at that time we need to change the things, and we need to think about the relativity. Otherwise, earlier we having the Galilean transformation equation, and Newtonian physics was self-sufficient. Okay, the base of the Galilean transformation equation was the Newtonian physics. Okay, so in which we take the speed of very small velocity. A small velocity means that a daily use type velocity that we use in everyday life. A speed of plane, a speed of train, a speed of boat. These all things that we use. Okay, so these are the very small velocity as compared to a speed of light. That is a speed of light. We all know that the speed of light is 3 into 10 to the power 8 meter per second. It's a very high speed as comparable to the speed that we encounter every day in our life. Okay, so these things have to be changed, and that we will see in the next lecture. That will the Lorentz transformation equation will come in picture, and this will simplify the problem of this when we have to move with another frame in a speed comparable to speed of light. Okay, and another postulate that he gave, the speed of light is 3 into 10 to the power 8 meter per second in all different frame and independent of relative motion. Okay, so if the speed of light in this frame is c, so it will be also remain c here. It won't dependent on the relativity. There is no effect of relativity will happen, takes place on the speed of light. Okay, so these were the two postulates actually, and he didn't give any experimental evidence for this, but these postulates changed the physics world and led to the discovery of a new subject, that's the special theory of relativity, relativity in the physics course. So that's all for this video, and we will catch up in the next lecture with the introduction of Lorentz transformation equations, so that we can see or solve the questions of the relativity. So hope you like the video. Okay, bye bye, take care, see you in the next lecture.